I explained to him my frustration with with the lack of funding, some rejections that I had. Then he just shifted the topic to something very enjoyable to talk about. This was his visualization of the Milky Way, uh, and he had been working on that. So we talked some more, and then it seems like we found some common points, and then we said, okay, let's work together, but exactly what? Yeah, more conversations happened, and but one big point was let's find some money. Um, in any case, our concerns met at some point, and we came together to talk about virtual lectures, and in a way that teaching would happen interactively, teaching and learning. So we started to write a couple of funding applications here and there, and then another, and then another, and then several applications later, like the whole bunch is a year happening over the last 2 years. I'll tell you more what happened with this. Uh, we we as we were looking for funds, and we instead of that, the first thing we found was a place, and our place is a room in the building, and I'll show you a little bit about that in a moment. So eventually, we got a little bit of money from the dean, and after a while, we started to work with couple of students, but after a few months, we just realized that we had just learned how not to get a project started. Um, Luckily, at the end of the year, we got a summer scholarship. We were able to find a very, very talented student, and also a couple more students. So at the end of 2018, we were already developing some work. And it was a fruitful summer. It was so good that we decided to scrap everything we had done up to that point and decided to start again. We started again. I'll tell you why, but before that, let me show you just a picture of the early days in which we were sitting together on a borrowed space outside our OGG building, and I was also wearing the thing in my office. But Shohil, who's not here today, I think, he found us a place on level 5. And this is, if you take a look at the screen, a little tour of the place in the early days. This was in the end of 2018, probably beginning of last year. And students who are not with us anymore, but they were working with us for a few months. At the bottom, you see here what we got to do at some point using somebody else's virtual environment. So this is a free software that you can download, this Alt Space VR. But this is what happened. At some point, these guys decided not to support this product anymore, and that's why we had to start all over again. A decision was made that we would start from scratch. So 2019, Aroaro 1 was on its way, but it was an evil year because it was full of teaching and other duties. And somehow 2020 is laughing at 2019 when we call it the evil year. But as what happened, we had to stop for a while, and a few months later, we were restarting the project. Applied to NBIE again, and guess what happened? Exactly, yeah, we got a new rejection. At the end of the year, we were seeking funding for the business school. We got it, and so luckily, since November, we have some more resources to work with. So this is what had happened to the proposals we have submitted over the last couple of years. One summer scholarship, the support of our school and the Oakland Foundation through a grant, and next summer, another summer scholarship, hopefully. We also got news 3 days ago about another rejection, but we are used to that. Anyway, so that's the story. So all that has taken us to immersive analytics. So let me just tell you what the literature says about immersive analytics. There's an interesting book that collects a lot of recent work on this topic. And the author says that immersive analytics is the use of engaging embodied analysis tools to support data understanding and decision making. Sorry for the typo there. So immersive analytics builds upon several techniques and technologies like data visualization, visual analytics, virtual reality, computer graphics, human-computer interaction. Most of us have heard these terms, and many of us have interacted with any of those or are a little bit knowledgeable about some of those. So hopefully this is not strange language to the audience today. And those things support data understanding and decision making, which could be either individual or collaborative. But immersive analytics is not tied to any specific technology. So basically, it's new kinds of display, like head-mounted virtual reality and augmented reality, or handheld and wearable devices. A lot of progress has been made in the recent years with this kind of equipment, plus interaction technologies like sensors and machine learning, especially in the gesture interpretation area. And all these are leading a new approach in data analytics and decision making. Basically, the authors of specifically the book that I'll show you before, the reference I show you, plus other sources, they claim that this will liberate us from the office desktop. So basically, it's getting us away from the office desktop to analyze data and visualize the data. So, but what is missing, and in this, many of the authors concede that what is missing is a fundamental knowledge of how to design these appropriate human-computer interfaces and data visualizations. And that's basically what we are trying to achieve here. Now, the opportunities for immersive analytics that they are actually go beyond the traditional analytics, and they are supported on, they are the following. So it's situated analytics. Basically, situated analytics is user-controlled data analytics information that is linked to objects in the physical world. Embodied analytics, which is moving away from the mouse and the keyboard and hoping that touch, gesture, voice, and tangible interaction allows a more intuitive and engaging data exploration. Collaboration, basically being able to either collocate it or remotely, asynchronously or synchronically interact with others. Spatial immersion, that's moving away from the desktop and using access to three-dimensional workspaces. And last, multi-sensory presentations that would help us with audio and other means to provide additional information in our work. And what we're doing at the moment, our Aroaro is heavily searching for opportunities on collaboration and spatial immersion. And you'll see in the demos that that can be suggested by the demos today, collaboration and spatial immersion. But we also explore opportunities on embodied data exploration and multi-sensory presentation to a lesser extent. All right, so I want to give it back to David because he would like to explain to us the architecture of our Aroaro.
Right. Okay, next slide, please. Okay, so we described the basic architecture of Aroaro as a peer-to-peer client, almost peer-to-peer. It's not direct peer-to-peer, and I'll explain why. But essentially, most of our development work is on a client, and the image in the center is a set of data which is being projected using HoloLens at Auckland Museum. So we can basically go into any space and place objects. At the moment, we are just placing little spheres and things like that. But right now, we're actually making it so that we can place any 3D objects into space and then actually leave them there. So when people come back, they will still be there. So the structure of the system is actually built using the Unity 3D engine, and contained within the client is a SQL-like database where we store all our data, and it's built over the top of a set of libraries called the Mixed Reality Toolkit. We connect to a variety of other, well, really any other cloud databases, and this one here, Cosmos DB, is just an example. So just moving up on the left-hand side, we're also just beginning to link in some work from various machine learning services in the cloud. We connect to data either directly off the machine you're running on. So mixed reality would be a PC, HoloLens would be HoloLens itself, which is in itself is a PC. We can read CSV files, JSON files, really anything, and bring them into our client. And we can also go out to URLs on the internet. Up in the top left-hand corner, you can see really a cornerstone of the system, Photon, which provides relay services. So, for instance, if I'm in this space in Auckland Museum and Fernando's somewhere else, then I can move an object, and he sees that same object move. I can highlight an object. I can create a new visualization, and so people from anywhere in the world can be present. And there's that word again, present, in the same space, in the same information space, even if we're not in the same physical space. In the center is Microsoft Azure, which we're currently using for speech to text. It's very difficult to type, especially in virtual reality. It's like typing with a long pointer, which is not great. And so any text we want, we can just speak the text, and that we send it up to the service, and we get back an interpretation of the text, which is extraordinarily good now. To support, we wanted to be able to support the ability to have logins, to be able to maintain users and all those sort of things, just the fundamentals of any system, and also to store various data. And we're using PlayFab, which actually Microsoft acquired about a year ago, and is used as a back end to many Xbox games, and it provides functionality at a really high level, so we didn't have to reinvent the wheel. So when you go into the client, we log into PlayFab, and then all the events and stuff like that are up there, and we can manage everything really. And then I'll just skip over those extensions. We actually don't have Aroaro connected to Canvas at the moment, but as part of a class project last year, Dan Richards, who's going to be demonstrating shortly, connected Canvas quizzes into a mixed reality space, and we're certainly going to go back and sort of take advantage of the work he did back then when it comes up in the priority list. As well, because it's designed as a peer-to-peer space, anybody can create their own Aroaro environment simply by going and getting a Photon ID and a PlayFab ID, plugging those into our client, and then they have a system which is completely independent of us. We have nothing to do with it. So hopefully one day people will start to be able to use this. So that pretty much covers the overall architecture. Okay, back to you, Fernando. Oh, I just mentioned that currently it's running on HoloLens 1. We've got some HoloLens 2s coming. HoloLens 2 is greatly enhanced over HoloLens 1. It's the augmented reality device. There's tracking of fingers and hands, and you can just pick up virtual objects in your hands, and many other advantages like eye tracking, etc. We also use the Windows mixed reality. In our lab, we have a number of these. They're really good because they're relatively cheap. Like HoloLens is $5,000. The mixed reality headsets are around $500. So we have those also for students who use our lab. My course is systems design. The students come into our lab and use it as a teaching resource. Just recently, we said, well, about time we branched out, and we built the software and loaded onto Android. And after about 2 or 3 hours sorting out a few little issues, we now have it running on Android. So somebody with an Android phone can come in and be in the same space. They can place objects into their physical world. They can walk around them, just like we can with the other devices. Of course, once again, it is through a little 2D space, but nevertheless, it works. And soon we'll have that on iOS as well. Okay, over to you, Fernando.
Thank you, David. So let's see Aroaro in action. I want to invite Dan Richards. He has been with us for some time already, and he can show us what is it that we mean by data visualization with one specific example on the Aroaro space.
Yeah, absolutely. So hi everyone, I'm Dan. So I've just changed the screen here. Hopefully everybody can see it. So this is the login screen that a user would be seeing as they attempt to log in. Because we log in about 30 times a day, we just have buttons for us. I just want to first mention some of the people that have been working on this project who aren't here today. Firstly, Aidan is one of the big developers that's been helping us. Really awesome person. I'm not going to talk about myself. David and Fernando have been leading it, and we've also got June in the call today. June, we've been helping her with her master's thesis, visualizing networks, and we'll show you that a little bit later on. So the really big point that I'm trying to get across here is collaboration. Because you can log in as different people, you can have your name on top of the headset that you're using, and also sort of personalize it a little bit. And other people will be able to see this on you, and as other people are also in the space, you can see their own color. Awesome thing is we can also collaborate with voice communication as well. We've just muted it for this instance because we don't want any feedback occurring. So going into our space here, we're on a beautiful mountain range. But we'll get straight into the data, shall we? So first of all, one of the big features of Aroaro is we can get data from any type of data source, or I should say from a lot of different types of data sources. So firstly, we could get it from a file that you have on your own computer, or if you were to use it, or a database. We'll use the database just because we already have that set up and ready for us. Now, in regards to the different types of data we can use, we can represent tabular data. Not only that, it can come in either what we call a CSV file, so very much like an Excel spreadsheet or a JSON file as well. Another cool feature is we can actually get these data sets streamed live from the internet and download it as an instance off the internet. So let's visualize this. So this is the coronavirus data set from a few months ago. We use this as a test data set, and let us visualize it. So as we come across here, we get a 3D plane. Now, one thing to put into consideration is as we use Excel, we can only see, say, an X and Y axis, only two axes at once. And a concern behind that is you can only see the relationship of two variables. The great thing about virtual reality is we can get 3 variables in there and start to really conceptualize the different things. Just while I'm here, I'll notice we've got David in here. I think he's got his headset upside down. Funnily enough, we could be talking now if we wanted, but yeah, we don't want any feedback to happen. So let me choose what's going to be on the x-axis. I'll choose latitude there of the different cases. Y-axis, so going up, I will choose total cases. Z-axis, let's choose longitude. Label, let's make it a country name. And boom, there we go. In fact, I think I want to see this data set just a little bit more clearly. So I'll make the background black and I'll toggle away the floor there. And I tell you what, I like green. Green's my favorite color. So as we start to go into the data set here, let me pin that over there, we can start to gain a really good conceptual presence of the data here. Let me move that away. So we can actually get a lot of perspective on the data and understand how they relate to each other. These are just a bunch of points. No, not quite. As we go over them, we can start to see the different values on them. And the cool thing is I've set it up in a way that if we look top down on them, it starts to present much like that on the map of the world. So let me go out, and to even get a better understanding and insights into our data, we can turn on all the labels at once. Obviously, with how many countries there are in the world, there's quite a lot of points, and help us understand that. So we can see places like India, Spain, and Italy all have higher cases compared to the rest of the world. And we could sort of see, well, if we look in this sort of area over here, which we can see as Europe, quite a lot of total, quite a high number of total cases there. So we can gain some insights like that, as with a lot of other things. So I'll yield back to Fernando, and we'll continue on with this demo a little bit later.
All right, thank you, Dan. So let me go back to the presentation. Where are we now? I think I forgot how to use them. I was so excited to be in level 3 that I don't want to think about so many more, but that's the thing that is helping us today. All right, so sorry about this, going slower than I thought. That was about tabular data. And what do we mean by network data visualization? Actually, what do we mean by network data? Well, network data, if we take a look at here, when we think of the normal data that we were talking about before, we call it tabular data. We have several entries on a data set like that. Each entry represents a unit of information, maybe a person. But when we talk about network data, what we do is we add a layer of information on top of the entries, the units, say people or countries or cities, any unit of information. We have the same units, but now in addition to the information that we have in a tabular data set, now we have relations between them. And those relations can be seen as edges, and the whole structure, we know it as a network, but actually a graph, but we call it a network as well. So this is the kind of object that we are referring to, and that object we want to visualize. So network data visualization is the use of embodied analysis tools to support enhanced understanding of data sets that feature, at a minimum, information about one-to-one relations between its data units, either in a unidirectionally way or bidirectionally, meaning the edges of the graph. So we have that. So we have some challenges here. We want to understand those network data. Why? Well, it turns out that the more we look into the information we have nowadays, the more we recognize that data is being produced from objects and from settings that we can regard as networks. The easiest to understand is a social social network, for instance. Many people want to have their hands on social network data because it's not only who belongs to the network, but also who is related to whom, who's linked to whom. And that's very valuable information. And learning from the object and being able to deal with the object, with that object called network, is important in many respects for many people. Now, visualizing that can help us understand the data in different ways. The old question here is whether 3D representations of abstract data can be more effective in these immersive environments than in non-immersive environments. And that has not been settled, and there has been some drawbacks, but also some progress. And we are trying to look at what has been more positive about that and how we can add to this journey. Now, if they can be more effective, then well, when or how or what settings, application scenarios are more suitable. So let us show you what we have achieved so far with net in regard to visualizing network data sets. And I want to invite Dan again to show us that for a short demonstration.
Howdy again. Don't think I need an introduction. Here we go. So quickly polished it up here to get to network data sets as we talked about. For those who are keen to know, we're representing this as JSON in the back end. But let's just go ahead and visualize it, shall we? So let me press this visualize button. I was a little bit silly because of lockdown. I didn't take a headset home, so I have to use this with my keyboard and mouse. This hand here represents one of the controllers that we have. So now we've got this data set up and running. Let me fly through it. So this represents, I believe, LinkedIn users or GitHub users. So I can see how they all connect to each other. John goes to Sankey, Sankey to Fernando. Hey, Fernando. Oh, look, there I am. We've got David there as well and Aiden. So let's pop out and we can gain a really good understanding and perspective of this whole network set. Keep in mind that we can, of course, visualize this in a two-dimensional space, but having that three-dimensional space, we really get a good understanding and good perspective on it. So let's say if I were to perform some queries. One quick thing we want to know, we use the term degree to denote the neighbors. So looking at Tia here, she only has one neighbor, that's Barton. And we would say that she has 1 degree. That's what we refer to here. So let's look at see who has the maximum degree. So we can perform some queries. And look, we can see Bill here has the most friends. Bill's very popular. Well, let's look at maybe the min degree, who maybe isn't popular. And we would expect Tia to pop up, wouldn't we? And we can see a few other people around the spot as well. So let me untick that one. Oh, you see it a bit bigger there, back to normal. And one other thing is, let's actually go straight over to Tia here. We'll perform a query on the degrees itself. So let's say I'll click this here. That max should be min and that min should be max. So what I'm querying for here is the nodes that have between 0 degree and 12 degree. So we'll see all of them are highlighting up here. However, let's say if I'm going through the query here, I can go past 1 to 2, and we'll notice that Tia straight away goes away, but Barton and you can see Anna, there's some blue specks there are showing that they're highlighted. Likewise, I could do the same where I go to 0 and only to 1, and Tia and Audrey, who only have 1 neighbor or 1 degree as we would say, are highlighted. So this shows how we can visualize and gain an understanding on network data sets. Again, I yield back to you there, Fernando.
All right. So the let's keep the image of the network. Can we please? Yeah. All right. So as Dan is going to go a little bit away from the network, I'm going to just mention quickly the main application that we are working on these days. Move away so we can have the appreciation of the network, please. Yep, on the distance. So these are only 50 nodes. That's a small network. This is just for the purposes of testing. the idea is that when we have larger networks in the hundreds and thousands, and we need to analyze the network, of course, there are already countless algorithms that can help us obtain information from network data sets. Actually, many graph algorithms in the fields of computer science and operations research and related fields, there's been a lot of work over the years. Now, one of those applications is around the concept of centrality. Centrality is a way for us to understand the importance of nodes in a network. That could be important to maybe marketing agencies if they are able to get their hands on network data sets, for instance. But there are many other examples where we would like to understand who's the most important person, node, or unit in a network. Obviously, degree, as you could see from the examples that Dan presented, is like the first kind of approach that we always have. But there's a series of measurements that talk about the importance in other terms that go from something called centrality. So that's the main concept here. They go from degree centrality to closeness centrality to page centrality. By the way, page centrality is at the heart of the algorithm that Google uses to determine the importance of a website, for instance, for which they get a lot of money advertising. So in our case, we've been working with June, who has been mentioned by Dan. She just finished recently her master thesis, and she was looking into how to use our Aroaro to help a team of people looking at network data make decisions about whatever they need to do using the concepts of centrality. And if we get closer to the network, I'm just going to, without a lot of talking about what exactly closeness centrality or degree centrality is, but just telling you it measures the importance of a node to the whole network in terms of being the node with, for instance, the highest degree. That's the simplest approach, but that concept can complicate itself a little bit more technically. We're not going into that, but it will give us a number. So if we can just activate the centrality, please, and get close to any of the nodes, we're gonna be able to see the numbers associated with a couple of nodes. For instance, degree centrality for Barton is a certain number you see there, 0.06. But if we go to a more important node, like area, you see that it goes to 10%, and any other node that with more built with more links, it goes to 0.24, as you can see. That's one measurement. The other is closeness, which is also technically defined. We're not going to do it here, but it will give us another measurement that people can use in determining who is who in the network. But not only that, suppose that instead of 50 nodes, you have, say, 5,000, and you want to explore part of the network without necessarily running complicated algorithms on the side on a computer that doesn't reveal much of the structure, but it's going to come up with a number, with a result. Well, our proposal here, our proposition is we can fly together into the network and explore those parts of the networks and jointly get to see the actual relations and the actual measurements that we want to get, and then make decisions about who do we want to contact or who do we want to try to reach in this network because of the whatever purpose we have in mind regarding accessing the people in this network. So we're going to leave it there because we are approaching the end of our presentation. But this is a nice demonstration. You can do it here on the screen, as you can see, but it is more exciting when you put this headset on your head and you explore yourself the network and fly into. So you are invited to our lab 587 in the building. All right, so it's thank you, Dan. I think it's time to return to David, and David is going to close, and then we'll open it for any questions you may have.
Okay. So we have the slides again, Fernando. Just while Fernando's, oh, here we go. Just while Fernando's bringing that up, I was actually in that space at the same time. You might have seen me in the distance, looking like a headset, but in fact I was using an Android device. So as I mentioned before, currently we've come a long way. But if you looked at our list of to-do items in our GitHub repository, wrong slide. You can see that we've got plans for doing a lot more, getting bugs out. Mind you, it's pretty stable, works really well. And as I said, we recently got onto Android, and we're about to get onto HoloLens 2. And recently we have just managed to borrow an Oculus Quest from the eResearch people, and so we're going to have a go at getting it on that. So we're attempting to get across many platforms so that people can use whatever they want. As far as actual functional developments, I'm just going to mention two. The first one, digital twins, which is actually in the bottom picture, which has become a very sort of trendy sort of topic. But essentially, there's all these sensors, all this IoT stuff out in the field now, and we can tap into data streams coming in and create well, digital twins in mixed reality. Like once again, there's nothing really new in this. There's been what's been called mimic panels in factories for many years, where people could sit in control rooms and control the factories, etc. The other area, and I've just put up this picture of the world with some data dimensions coming out from it. And I'm not saying all our points are going to look like this, but we're also those spheres, pretty boring looking points. We're soon, well, right now we're developing so that we can put any 3D object on there. So for instance, if we wanted to represent an orchard, we could plot a series of trees, and then you can come up with a scenario where somebody wanders down through the actual orchard, and when they get to a particular tree, it might say have a mark. They're wearing a HoloLens, for instance. They can see a mark on a branch that needs to be cut off that somebody has decided, and they can go and do that work. And as well with multiple dimensions, once again, because of the space we have, because we can see so much more in room space or world space, then once again we are hoping to make access to data and hence decisions about data easier. Okay, so that's pretty much us. So over to you, Fernando. You're muted, Fernando.
Yeah, so this is the moment to say thank you to the audience, but also invite you to comment or ask any questions you may have. Just unmute yourself. You can think you can do it and start talking, please. I know Lek wants to say something, but probably he's too shy today.
Another thing as well, if you like, feel free to ask a question in the chat if you're not feeling up to using your voice. No worries with that.
Somebody called me to the front desk, right?
Yes.
Well, look, I look on this with great interest for many reasons, but one of them is that I have a recording of a tool which is used by, let's say, Israeli Secret Service, and that recording was done 6 years ago. And practically what they were showing on that recording was exactly what you guys are doing, but at a two-dimensional space. And you may easily guess that they were after contacts between people. So practically, if you issue a topic of interest, any social group which are discussing a specific topics, then immediately you may get the indication what groups are talking about these topics, and then what are the members of each of those groups, and then what are the activities of those groups. Like, for instance, who is the most active member, what was the frequency of the contacts within the group, frequency of contacts between groups, location of those people, and of course, if there is necessity, then it was possible to add some graphics. For instance, if you would like to find out location of those people, immediately the map of the world pop up and you will see physically where they are located. So practically, I believe what you've done is some sort of a very nice extension of that contact in that application, what I've seen. But I don't think that you have a contact directly with those sources.
I would like to think that we're giving the ordinary person the ability to do what the Israeli Secret Service are doing right now today, and yeah, exactly.
That's like David's dream. He wants to put Aroaro on everyone's Android device. I think we're getting closer and closer to that dream, to make that dream come true, actually.
I also see it as well, because we can put it on something like an Android or something like that, or an iPad or whatever. And you can see it's pretty easy to open up a data set and have a look around, even for education for school children. You know, like there's nothing there that a child of 10, 11 or whatever couldn't use. So maybe that's an area that we'll find some interest.
Certainly. So I was looking at the chat. There were a couple of compliments there. Thank you, Farhan and Ruhi. But any other questions or comments?
Hi, I just want to ask something. Can I?
Yes, please.
Yeah, so first of all, fantastic presentation, as I said. David mentioned about some Canvas extensions which are proposed with Aroaro. So is it a work in progress, or what? I mean, can we use this with Canvas for collaborating or something for quizzes? Maybe I missed on that, probably. There was something on the architecture of Aroaro with Canvas extension.
Oh, there we go. Okay.
Yeah.
So yes, well, in my information design class last year, Dan Richards, who was presenting, was in that class and presented a fantastic project with his group, and they came up with actually connected to a Canvas quiz. And so people were able to actually set the quiz up in Canvas and then actually take the quiz within the mixed reality space. And it was something like looking at gravity, if that was right, Dan, I think. And he had pictures of the different planets, and you had to work out by dropping hammers on the planets which had the greatest gravity, something like that. So I mean, it was a prototype. We haven't extended that work any further, but I'm sure if there was an interest and a few dollars, we'd be happy to do it.
Yeah,
we'd love to talk to you about it. Yeah.
Yeah, it must be a good experience to conduct a quiz in that manner. Yeah. Thank you.
I should just say that like a year ago, our focus was very much on how we could use mixed reality in teaching and learning, and and we looked at that, and like there's some very obvious cases like in medicine and engineering in the very physical world, and then we were started thinking about how can we apply this to business, and our initial thought was, well, you know, business is driven a lot by information and for decision making, and so we've been going down that path since then, but we haven't abandoned the teaching and learning path either. So the environment that we've built could support really any objects. Like at the moment, the objects of interest that we have in there are data sets, but
Yeah.
we can put any objects of interest in there, where the digital twins comes in. Yeah.
Right, right.
All right, so there's a question from Andrew Patterson. He's asking, can you explain the main benefit of 3D data visualization over 2D? What are the benefits of the third dimension? Briefly, back in the 1990s, when the devices started to get much better, and actually it's the times of the silicon graphics, maybe you remember, which promised a lot of quality.
Sure, Andrew doesn't remember.
If you David, remember, and there was someone came up with a way to represent hierarchical data, and that was known as a cone tree. Basically, it was a way to explain how data that would present itself in hierarchies you could understand it if you, instead of having it on a plain graphic, you could actually produce some sort of a cone where you would see the different levels or hierarchies of data coming out in the hundreds, for instance, which made it more difficult to appreciate. But that sort of early applications, early tools were not they were promising for a while, but the problem is that people started to quickly sort of lose faith in these things because of a lot of issues with the actual technology, visualization technology, and but visualization has come in waves, and the waves have been pushed by improvements in technology. So when a new improvement comes, then people rush to do things, and then for a while things seem to be active, and then they just come down and the next wave comes up. So there's been recent progress on devices like HoloLenses and other devices with higher quality in all respects, especially on those aspects that have to do with how the eyes are able to react to the visuals, and the big questions that people in the area have, and it's still an open question, is whether we should just rely on simple quote unquote simple 2D information visualization, or which situations lend themselves to this 3D approach. In our case, what we've been able to establish, at least very simply from the examples and the cases we have, is that at least in network data visualization, one of the problems that you have when you want to see the network is that in the plane, as long as the network is not that crowded in terms of the links, which is called a sparsely populated network, then you can sort of see that. If that's your interest, to see the network, to see the relations and try to find what you're looking for. But if the more crowded it gets in terms of the density of the links, the number of links and the number of nodes, large networks, then if you're able to penetrate somehow the network in a representation like the one we showed today and fly into the network and focused on either parts of the network if you want, or go back and see the network from the distance and use the type of solutions that Dan and Aiden have helped us with, like color changing or shape changes in shape of the nodes, that sort of thing, then you start to appreciate the power of this way of representation. From that perspective, I think we have at least a case that we can work on. Obviously, we need to test these things. The thesis that was just recently finished started to give us some kind of idea as to what to test and how to test it.
I would say that for me that it's really simple. If you're looking through a little two-dimensional screen, and all of you are looking at our work through a two-dimensional screen today, so it's no different from what people have done for years. But when Dan was demonstrating, he was in the network. He was moving around within the network. I was also in there as well. And I was looking at the network from the other side. So, and other people, if we were in there discussing it together, then we would be looking at this, or what I call the object of interest, and in this case, a network, that could be anything. We're looking at it from different viewpoints. We can move around it. We can annotate it. We didn't talk about annotations, but we can annotate the network. We can leave markers there and say, look, here's an interesting, I'll use the word cluster, if you like, because we're all into clusters at the moment. So, and in the first slide I put up, I said, you know, we're moving from this very limited 2D space into an immersive world-sized 3D space. And we don't have time today, but I have actually filmed outside with data spread amongst trees. So you know, like it's until you try it, if you try it, you'll know it. You know, but you know, if you've never dived into the sea, you don't know what it's like.
That's a good point. Yeah. We can try the last question. Andrew had another question, but I'm going to skip. I'm going to skip Andrew, and I'm going to invite Prajia. That's your name.
Yes.
Yeah, please.
Hi, my name is Gege from Marketing Department. I really enjoyed the presentation, especially since it has to do with my research. My research is on family consumer research. My focus is on family dynamic on conflict resolution in purchase decision-making process. I plan to use VR as a cutting-edge methodology to explain human interaction. In my case, in family interaction. I'm glad that University of Auckland has started the same direction with Stanford University, which has the virtual human interaction lab. If you heard about it, if I may to join and collaborate, I keen to set another meeting to talk about it further.
Certainly.
Thank you so much.
There are 3 places in the university, as far as we know, the research center and another one in engineering. They are doing a lot of stuff with virtual reality and augmented reality, but in the area of data visualization, at the moment it is us, and it's mainly because of our position in the business school, right? So data for us is definitely one the thing to deal with. But certainly more than welcome. So I would like to finish inviting everyone. You know, the room is 587. 587 or 578? 587. We are in the middle of the finance and accounting department. So yeah, at any time, or just contact us via email, and we'll be happy to share with you at any time. All right, so
thank you so much.
No, thank you. It's 2 o'clock, and I think it's time to close this session. And thank you for your presence, your Aroaro today with us.
Thank you.
Thank you, David. Thank you, Dan.
No worries, thank you.
Bye, everyone. Thank you. So we'll talk later. All right.
Cool. Okay. No worries.
Right.
Thank you. Bye.
Good
See ya.
All right. Bing, bing, bing.